Hey everybody. So today in this video I want to talk about linked lists. Now linked lists are a data structure, and what a data structure is, it's simply just what we call the way of organizing your data in memory so that you could easily and efficiently access it. So the way you do data is stored, how it is arranged in memory, and what you can do on that memory is all what data structures is. And it'll probably be the next class that you guys take. So we've already done data structures. We just haven't called them data structures. We've done arrays, right? So an array is a data structure where you're sequentially putting all of the data in a section of memory that you're going to be accessing through elements one by one through the element list, right? And you can go anywhere in that element list that you want and access the data. The couple things about it, right? It's fixed size. We can do dynamically allocated arrays, but that also requires pointers. And so then we have linked lists. And so linked lists, and the one I'm showing here is a LIFO one, which is last in, first out. But a linked list is a data structure that instead of storing all the data in a sequential row, it is storing the data in things that you need at the time you need them, right? So you'll block off a block of code, a block of memory, sorry, when you need it, and then you'll point to a new section of memory when you're going to need to add more data. And so data is not necessarily sequential, but it is linked, hence the name linked list. It can start off sequential, depending upon where you're putting it in memory, but eventually it will end up not being sequential. So there's multiple types of linked lists. There's singly, doubly, and circular linked lists. So these are images that I got from Geeks for Geeks website, and that kind of go through the three different types of linked lists. So what a linked list is, you have a section where you have data that you're going to be storing. You're going to have a pointer that tells it where the next section in memory, right? All the pointer is pointing to an address location in memory. And so we have a pointer that's pointing to the next location of where that data is going to be stored. And then you'll have that data with the pointer that points to the next one. And the last one on the list is going to point to null, because that means that there's nothing left, right? So that is called a singly linked list. That means that you traverse the list from start to finish, from the head to the tail. It's usually called the head and the tail. A doubly linked list is kind of doing the same thing, except instead of only having a pointer going to the next one, you also have a pointer pointing to the previous one. And so this one, right, is going to have a previous button or previous pointer going, and it's going to start off at null. So you have the head with the data, and so the previous one goes to null, the next one goes to the B1 data, and then that previous one goes back to the A, the next goes. So this one takes a little bit more memory of storage, but the benefit of it, right, is that now we can easily traverse the whole array going backwards and forwards, right? We know where we've been and we know where we're going, and so we can easily go back and forth either way. The problem with a singly linked list is if you get to C and you want to go back to A, then you have to just start over, right? You can't go backwards. You have to just start over. And then you have the circular linked list. The circular linked list only goes in one direction, but instead of having the last one go to null, it is printing back to the first one in the list. And so the benefit of it is, right, that you could keep going around and around when you're needing to do anything with this list. The main thing I want to cover today is the singly linked list, just because to introduce, I find it always easier just to start off with the basics. So a singly linked list, you might already know about these kind of things, but there's two ways of adding to it. You could either have the first in, first out method, and this is like stuff like, you go to a queue at a coffee shop, you earn a line, or anything where you're like, you get in a line and you're gonna buy stuff, any kind of queue, right? So like a print queue or even network packets, like um, all of our data gets sent across the traffic of the network, and it processes the data the second it comes in, right? So that's the queue method, right? And this is kind of an image that I got from this All About Lean website, just because I liked the imagery of it, where you can see, you add a queue, and it's like that gets added, and the first one that was added comes out, right? Then you have LIFO, or last in, first out. And this is where you have things like your undo button. So the last thing you did is the first thing that pops off. Your browser back button, right? And that kind of shows you a double linked list, right? Because you could hit backwards and then also go forward, so it keeps track of where you've been on both sides. Or like a stack of plates, like you put plates on, and that's kind of what this imagery looks like, right? Is you stack plates on top of this, and so the last plate in is the first plate out, right? Some benefits of linked lists. The main thing is that you don't have to know how big of data or how much data you need at the start to be able to allocate your data, right? With an array, you need to know that you're going to have 20 elements in the array. This one, you only build it with one. That's all you need to know at the beginning. You only use one. And so you're only using the memory that you need. So you never are, it's a very efficient memory usage. You're not using more memory than you need. It's also easy to insert and delete. You don't have to like move anything. All you ever have to do is just assign the pointer and change the pointer of where you're pointing the data to insert something or to delete something. You can delete it the same way. Some problems with it, like in an array, we could say we want to go to element 4, and it's easy. In a linked list, you have to go to elements, like you have to start off at the beginning, at the head, go to the next one till you find your fourth one in the array or in the linked list. So that's a more inefficient method, right? So it's slower to traverse the array, or it's slower to traverse than an array, right? And what I mean by that is, like, to go through each element, you have to go through each element to get to where you're wanting, whereas with an array, you go immediately to it. And it does require an extra memory location for adding the pointer, so it can be a little bit more storage depending upon what you're needing. In the next video, I will walk you through how to actually start creating a linked list using CLion and C++.